So the first problem we're going to look at is this is a circle. So I know it's a circle because I have my x squared and my y squared. So I have an x squared and a y squared and it just equals some number. There's no denominator down here. So I know that that's not going to be an ellipse or a circle. I mean, an ellipse or hyperbola, so I know it's got to be a circle. I know that my center is at 1, negative 3 because I use the opposite of the terms here in the middle. Then my radius is going to be the square root of 20, because remember this right here, that number is r squared, and the square root of 20 is about 5.4. Okay, so now if I wanted to graph this circle, I just draw my xy axis. I go over 1, down negative 3, plot my center, then go 5.4. So I go up 5, 1, 2, 3, 4, 5.4, which is about right there. To the right, 1, 2, 3, 4, 5, and then a little bit more. Down, 1, 2, 3, 4, 5, and a little bit more. And then to the left, 1, 2, 3, 4, 5, and a little bit more. And there's my circle. Oh, I'm going to draw that a little bit better. Okay, so there's the circle. Now, let's look at the next one. This one I know is an ellipse. And the reason I know it's an ellipse is because you have this minus sign here, and this minus sign is going to tell me that it's an ellipse. So for an ellipse, there's a couple things we look for. The first one is the center. And the center is just like we did on the last one for the circle. It's going to be at 0, 4. Now remember that you got to look for the x term. So here I have my x term is 0, my y term is 4. Remember, the first term, your h, always goes with your x, and your y always goes with k. Okay, so there's my h and my k. Then after I find the center, I want to find the vertices. Now the vertices happen at h, k plus or minus a. And in this problem, let's figure out what our a, our b, and our c is. So our a is whatever this first number is, and in this problem it happens to be a 1 right here. So no, it's the square root of that, so 1. Our b is going to be the square root of 9, or 3. And our c is going to be the square root of 1 plus 9, or the square root of 10, which is about 3.1. Okay? So here, our vertices are going to be at, remember that in the reason why we're at h, k plus or minus a is because we have a vertical ellipse. And the reason we know we have a vertical ellipse is because here the y is first. Okay? So I know it's going to be at 0, 4 plus or minus 1, or 0, 5, or 0, 3. Because here I know first I'm going to add 1, and then I'm going to subtract 1 from 4. Then I want to find my foci. And my foci in this problem are at h, k plus or minus c, which has to be 0, 4 plus or minus 3.1. And those 2 points are going to be at 0, 7.1, and 0.9. Okay, and the last thing I want to find is the asymptotes. And the asymptotes in vertical ellipses happen at y equal plus or minus a over b times x minus h plus k. So that's going to be y equals plus or minus 1 over 3 times x minus 0 plus 4. Now if I want to graph this, I'm going to go on to the next page and show you how to graph it. So the first thing we're going to do is we're going to draw our center. So here's our xy coordinate plane, and our center in the problem was 0, 4. So I'm going to go to 0 and go up 4. So that right there is going to be my center. Then I'm going to find my vertices. My vertices in this problem are at 0, 5, and 0, 3. And I'm going to draw those vertices in red. So 0, 5, 0, 3. Now what we want to do is we want to plot our foci. And I'm going to plot our foci in red. It was 0, 7.1, which is a little bit above 7, and 0.9, which is a little bit below 1. Now what I want to do is I want to draw my asymptote. So what I'm going to do is we know up 1 over 3, so up 1 over 3 from my center, and go down 1 over 3 from my center, down 1 to the left 3 from my center, and up 1 to the left 3 from my center, and then draw my lines through those points. And there are my asymptotes. And then the last thing I gotta do is just draw my hyperbola. And remember, it goes really close to the asymptote, hits the vertice, gets really close to the next asymptote. It does that on both sides. So really close to the asymptote, hits the vertice. Gotta redo that one. It's gonna get really close to the asymptote, hit the vertice, get really close to the other asymptote. And there are my hyperbola. Now, you also have ellipses and parabolas you got to graph, so make sure that you look at the example that are posted on the website of the ellipses and the parabolas, okay?